Hi everyone, my name is Chipran. I am from CUCG section. My topic is case study in Amazon. Introduction. Amazon is one of the world's largest e-commerce and cloud service provider. It relies on robust software architecture for scalability, reliability and performance. Adopts design patterns to streamline system development and maintenance. The architecture supports millions of transactions per second. This case study explores Amazon's software design and engineering excellence. Evaluation of Amazon architecture. Initially built as a monolithic application in the early 2000s, shifted to service-oriented architecture (SOA) for modular scalability. Transition into a microservice-based cloud architecture. Continuous evaluation towards serverless and event-driven system. Goal to achieve agility, performance, and global scalability. Software architecture overview. Microservices from the backbone of Amazon system design. Each service handles a specific business function like orders, payments, etc. Independent deployment enables faster innovation cycles. Services communicate through REST APIs and even BZs. Highly decoupled design increases fault tolerance and maintainability. Key architecture goals: high availability across multiple regions and zones, elastic scalability for unpredictable traffic loads, fault isolation and minimal services downtime, data consistency and low latency responses, security and compliance in all transactions. Microservice architecture. Amazon uses hundreds of microservices across business domains. Each microservice owns its own data storage and lifecycle, communicating via APIs or asynchronous messages like SNS or SQS. Microservices allows independent scaling and update, enable Amazon teams to operate autonomously to pizza teams. Design pattern used. Observer pattern used in event-driven system for notification. Factory pattern for creating service object dynamically. Singleton pattern ensures single instance for critical components. Circuit breaker pattern prevent cascading failures in service call. Proxy pattern used for security and API gateways management. Load balancing and scalability. Elastic load balancer distribute incoming requests evenly. Auto scaling adjusts instance based on real life trafficking. Design patterns like strategy and adapter ensures flexible scaling logic. Data partitioning ensures optimal performance under heavy load. Amazon architecture achieves near zero downtime at scale. Data management pattern. Each microservices maintains its own database, polyglot persistence, CQRS is command query responsibility segregation, separated read-write operation, event sourcing maintains historical states for auditing and rollback. Sharding and replication improves query performance. Consistency ensured through distributed transaction pattern. API gateway pattern. API gateway acts as a single entry point for all client interactions. Handle authentication, routing, and throttling. Implement the Ficket design pattern to simplify client access. Sports caching for performance optimization. Integrity seamlessly with IAM for secure API access. Event-driven architecture. AWS SNS and SQS handle asynchronous communication, reduces coupling between services for high resilience. Event producer and consumer operate independently. Facility scalability and real-time responsiveness. Ideal for large-scale systems like Amazon's e-commerce backend. Observer pattern action applied in inventory and order system in trigger real-time updates. Notifies dependent services upon stock change or order placement. Decouples event producers and consumers for modularity. Enhances responsiveness and automation in the ecosystem. Commonly implemented using AWS Lambda and SNS. Repository pattern separates database logic from Business logic improves code maintainability and reusability, simplifies database migration and testing process, used in Amazon product and order management system, promotes cleaner architecture and lower technical debt. Service discovery and registry. Amazon use services registry for dynamic service discovery. Avoid hard coding services endpoints in configuration. Implement design pattern similarly for register and proxy. Ensure efficient and scalable and dynamic cloud distribution. Managed through AWS Cloud Map and Route 53. Security architecture follows the principle of least privilege for access control, integrates IAM for identity and role management, implements API gateways, WAF, and encryption standards, adopts decorator patterns for dynamic request validation, ensures secure inter-services and customer communication. Caching strategies. Caching layer used to reduce latency and database load. AWS CloudFront and Elastic Cache provide content distribution. Use flyweight pattern for lightweight objective reuse. Improve user experience during peak shopping period. Support global content caching across regions. Fault tolerance and recovery. Implement circuit breaker and retweet design patterns. Automatic failover between data centers ensures uptime. Graceful degradation maintains service continuity. Continuous monitoring using AWS CloudWatch. Chows ensuring test system resilience under failures. Communication pattern. RESTful APIs for synchronized communication, event queues and pub sub for asynchronous workflow. Saga pattern handles distributed transaction, correlation ideas ensure traceability across services, ensure consistency and observable interactions. Continuous integrity and deployment, in shortcut form CI/CD. Automated pipeline manage build, text and deployment, follow the template method pattern for reusable stages, uses AWS code pipeline and Jenkins for orchestration, reduce deployment risk and blue-green deployment, ensure continuous innovation with minimal downtime. Cloud infrastructure pattern. Implement infrastructure as a code in via AWS Cloud Formation. Applies builder pattern for environment provisioning. Immutable infrastructure ensures stability and repeatability. Support hybrid and multi-region cloud architecture. Facilitates automated scaling and configuring management. Serverless components. Adopt AWS Lambda for event-triggered execution. Reduce infrastructure overhead and cost. Implement strategy pattern for flexible handler logic. Used in notification, monitoring and lightweight workflow. Scales automatically based on event frequency. Monitoring and observability. Implement centralized logging using CloudWatch and X-Ray. Applies observer and chain of responsibility patterns. Tracks latency, errors and dependency health. Ensures visibility into distributed workflow. Supports predictive scaling and anomaly detection. High availability design. Multi A to Z deployment ensure fault tolerance. Geo replication improves data redundancy. Load balancer distribute requests across health zones. Ensures disaster recovery using backup and restore policies. Supports SLA, communicates exceeding 99.99 uptime. Performance optimization. Use performance profiling and caching patterns. Minimizes database calls via data aggregation. Layers. Implements asynchronizing pattern for high responsiveness. Scales horizontally with distributed system approaches. Optimize latency through CDN and APN caching. Innovation, continuous improvement. Encourage experiment with new AWS services. Refactor legacy system using modern patterns. Conduct regular design reviews and architecture audit. Invest heavily in developer tooling and observability. Focus on customer experience as a design driver. High availability design, multi A to Z deployment ensure fault tolerance. Geo replication improves data redundancy. Load balancer distribute requests across healthy zones. Ensure disaster recovery using backups or restore policy. Support SLA communities using existing 99.99 uptime. Innovation continuous improvement like conduct regular design reviews and architectural audit. Invest heavier and developer tooling and observability. Focusing on customer experience as a design driver. Conclusion. Amazon explips scalable and resilient architecture design. Combines microservices, design patterns and automation. Patterns ensure system consistency and extensibility. Cloud native architecture enables agility and innovation. A continuous learning culture sustains architecture excellence. Thank you all.